Hello, everyone. We will be starting with the session. Good afternoon, good morning, good evening, dear authors and invited guests. Welcome to the technical session 11B. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GI Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, ICICT 2025, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18 February in London, UK, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we will have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for the session. Professor Eduardo Pinos Velez. Sir is a professor at Salesiana University at Duarte, specializing in research and development, IT project planning, web content development for people with disabilities, and ICT solutions for accessibility. With expertise in mechatronics, biomedical engineering, and bioethics, his research interest basically lies in ophthalmology, electronic engineering, computer architecture, artificial intelligence, and artificial neural networks. Welcome to the session, sir. I would also like to take a moment to introduce you to our session chair, Dr. Poonam Railkar. Ma'am is currently working as an associate professor in the Department of Computer and Energetics and Srimati Kashibai Nawale College of Engineering, Pune, India. She has published 30 plus papers at national and international journals and conferences and authored one book. Her research interests are Internet of Things, machine learning, security, and database management system applications. A very warm welcome, ma'am. Would you like to share a quick opening remark with us?
Thank you, Anjika, ma'am. Now we will start the session, and at the end, we will give the closing remarks.
Sure, ma'am. Thank you so much. So we'll be starting with the papers. On request, first we will be having etiquette to present the paper titled Design and Implementation of a Secure and Efficient Blockchain-Based Investment Platform with PVFT Census. Are you there?
Yes, I'm here.
Yeah, you may present now.
Okay, so first I would like to present myself. My name is Atikur Rahman, and I'm a doctorate student in France, and also I work as a full-time blockchain engineer. So I will be presenting my work. I hope my screen is visible to you, my presentation.
No, your screen is not visible. Kindly share your screen again. Yes, we can see your screen.
Okay, so you can see my screen now.
You may open your presentation.
Yeah, now you can see my presentation, right?
Yeah, we can.
Okay, so the topic of my presentation is design and implementation of a secure and efficient blockchain-based investment platform with the PBFT consensus. So I would like to begin with that. Why do we need a blockchain inside an investment platform in particular? So before that, we used to have a traditional investment platform, which used to rely upon centralized system. It means that it does not have any a decentralized system, and it just have only one power, which is the supreme one, and he can monitor the application as he wants. Another one is the blockchain. It provides security, transparency, and automation. And how does it do this? We will see it on the coming slides. And when it comes to the design pattern and how we are going to make this feasible, we can achieve it by event-driven architecture and ensure real-time processing. And the other part is this presentation will cover the architecture of the blockchain integration and a bit of DevOps. So now I just looking on what actually is an investment platform. For example, there is an application on which an investor pass an order to purchase some share of a company. So the working would be the person will go into the front end of the application. It will create an order, and uh, the order will be recorded. So when we use blockchain inside it, we do have brokers, which are the smart contracts. So smart contracts are nothing, but uh, it is some rules and regulations which are written electronically. It means some program is performed. The settle the settlement of the order is recorded on the blockchain. So it has the snapshot of the order, which which has the crucial information that what order has passed, and also we can record portfolio updates and notifications. It also and for example, the main is compliances and audits. So via a smart contract, we can easily achieve that. So coming up to the feasibility, what is an event-driven system? So event-driven system is normally a reaction to an action. So whenever a user pass an order, some reaction is to be done. Pass an order, then something to be recorded. So for example, if a user is passing an order, then there will be something which going on in the backend of the application, which will create the order. And um, so what we on the traditional systems, what we do is we do not have event-driven architecture, and we are totally relied upon the uh, three-tier layer of the application, which may lacks, and it is not also the scalable. By using event-driven architecture, it also processes fast. It has great flexibility, and the scalability also improves. So here we come the how the event-driven system works. So event occurrences. For example, if you go in any of the application, let's say you submit a form with your name, email, and everything. Of what it will do, it will create an event and it will send it to the other layer of the application like a message. It will not store it directly. And after that, for example, when you produce an event, then there are the producers and also there are the subscribers. So when you produce an event, it is subscribed by the other services so that the action can be completed. Now, what will be the architecture of this application, and how we are going to interact in the different components of the application. So normally we would be working on the distributed system. So distributed systems is we do not have everything coded in a single file. We do have different services which interact with each other to perform a single function. So looking up to how distributed system works. So in distributed system, work is divided across multiple services. Apart from it, we have the node communication. So if there is a function which is done by A, and it also has some part to B, so the A will say, okay, here is something. So A will interact with B to complete that function. Now coming to the consensus and coordination. So normally blockchain is based upon the consensus mechanism. So which is like if I have to perform an action, then I should have 60%. For example, I should have 60% consensus. So if there are 5 nodes, I should have 3 working. So if I have to perform a task, I have to I have to take in confidence at least the 3 nodes so that the work can be done. Now, what is a fault tolerance? So here fault tolerance is, for example, you have several nodes connected and working together, but one of them get infected. So how it's going to work? So for that, we do have PBFT algorithms which do take care of the fault or the faulty nodes. Now, how do we integrate blockchain inside a normal application? So in normal application, we do have front end, back end, and database. So what we do, we add smart contracts, which is an additional layer on the backend part. So what all the functions is done by the application, it creates a record over the blockchain, and blockchain records it into a database, which is normally known as low-level database. And the example for it is we say CouchDB. So we do also have, like in particular for the investment application, we do have decentralized identity. We can store decentralized KYC as well. And this an on-chain settlement. It means that what all the transaction is being done, it is transparent to everyone. Now coming to reliability and security enhancement. It's immutable records, because once the block is generated, you cannot you cannot modify. Smart contracts, it's automate the regulatory compliances. For example, let's say I live in France, and if I have to purchase some shares, so I have to go through the rules and regulation of France. So a smart contract do take care of these regulations. Decentralized storage. So there is no only one supreme power over the application or over the transaction. And of course, consensus mechanism, which I just explained. So now looking for the DevOps part, we can use Terraform, which is, or Ansible, that is like a infrastructure as a code. And after that, we can have, of course, CI/CD pipelines. And for containerization, we can use Docker. And we do have other parts to monitor it, like we have like Grafana. So coming on the conclusion part, blockchain enhances security and automation in investment platform. The event-driven architecture improves system scalability and resilience. DevOps practices ensures continuous delivery and system reliability. And I believe that in the future researches, we can explore more benefits of the blockchain when used in a normal software application. Thank you very much.
Thank you so much for your presentation. Ma'am and sir, do you have any questions? Ma'am and sir, do you have any questions? Okay, I guess no questions then. Oh, okay, ma'am has questions. Ma'am, you're not audible. No.
We can hear you.
Oh, no, ma'am, we cannot hear you. Sir is audible, but you're not audible.
Can I make a question?
Yes, sir. Sure, go ahead.
Thank you. Good morning, everybody, and thank you, Professor, for sharing this research. So I have a little question. What is the future of this work, and how to make it believable for everyone?
So the future of this work is
Yeah.
if we can create fintech or like financial application more trustworthy, transparent, and more above that, more secure.
Okay,
So
thank
for
you.
example, like in my present enterprise, I have been working with a distribution of a blockchain called Hyperledger Fabric. So what all we do is record it on the Fabric, which, so if anybody wants any record of data, I know like we have normal databases which we can provide us, but when it comes to like blockchain, we all know that it can never be modified. So it of course provides some trust. So yes, that's what I mean.
Thank you.
Nice. Thank you.
Thank you. Ma'am, would you like to continue with the question? No, ma'am, you're not audible. Sure, ma'am, no problem.
Ma'am, you can write your question in chat box if it's not possible.
Yes, ma'am, if you are encountering some problem, then you can write it also. I would read it for you. Sure, ma'am, you can read on. There is no problem. We'll just wait for 1 minute and then we'll continue with the presentations. I guess ma'am is here, so we'll be moving on to the next presentation now.
Thank you very much.
Yeah, thank you. So next up, we have Connie to present the paper title, Automated Identification and Analysis of Barrett's Taxonomy Levels in Reading Comprehension Assessment Task, a GPT-based approach. Are you there?
Yes, hello.
Yeah, you may please begin presenting your paper.
Okay, I'll share my screen.
Yeah, you can.
Can you see my screen?
Yes, your screen is visible. You may begin.
Okay. Good afternoon. My name is Connie Gofre, and today I will be presenting my team's work named Automated Identification and Analysis of Barrett Taxonomy Levels in Reading Comprehension Assessment Task, where we use ChatGPT as an experiment tool. Okay, so 1 second. Our research focuses on the educational field, specifically on how artificial intelligence-based computer tools can support educational institutions and teachers. In education, the design of didactic or evaluative tasks inherently involves a level of cognitive demand for students, which is determined by the learning objective proposed. For reading comprehension tasks, questions should assess understanding progressively, aligning with cognitive levels such as memorization, interpretation, and evaluation. And one of the most effective ways to identify these levels is by using taxonomies or models that facilitate the structured development of assessment items. A taxonomy describes the cognitive process a student engage in while completing a task, and various taxonomies exist for defining cognitive levels, and some are applicable across multiple subjects, while others are subject specific, like in this case of this work. In this context, the most recognized and widely used taxonomy among Spanish language teachers in Chile for designing reading comprehension assessment tasks is the Barrett's taxonomy, which is the one that we use. Research has shown that teachers often face challenges when creating or categorizing tasks using a taxonomy. And also this process can be slow, subjective, and costly, making it difficult to ensure consistency in task classification. So in our study, we explored the use of ChatGPT to classify cognitive demand levels based on Barrett's taxonomy. Specifically for assessing reading comprehension tasks in Spanish textbooks. We then compared the AI-generated classifications with those provided by a panel of experts to evaluate its accuracy and reliability. Barrett taxonomy defines 4 levels of cognitive demand. They're ascending in order of complexity, provided a structured framework for evaluating reading comprehension skills. The methodology we use in this study was developed in 3 key steps. The first one, the data collection. We selected reading comprehension assessment tasks from the 2024 Teacher's Guide for the language subject, Spanish in Chile, designed for 4th grade of primary education. These tasks included a series of readings in Spanish, followed by questions that were intended to assess students' ability to comprehend the text. The selected tasks were varied to ensure a broad representation for all the levels of the taxonomy that we use. The second step was to use the ChatGPT to automatically classify the selected tasks according to the cognitive levels of the defined Barrett's taxonomy. And this process was aimed to evaluate how effectively an AI model could categorize the tasks based on their cognitive complexity, from lower level skills such as memorization to higher levels like analysis and evaluation. And the third step was we use a panel of experts consisting of educators and specialists in the field. They also classified the same tasks, and their classifications were compared to those generated by ChatGPT. The goal was to evaluate the accuracy and consistency of the ChatGPT classification, identifying any potential discrepancies or areas where human judgment and AI classification may align or differ. The experiment that we made, we selected 4 reading activities of reading comprehension, which included a total of 25 questions that were given to ChatGPT-4 for classification. To ensure clarity and consistency, we provided ChatGPT with a prompt that you can see in the screen at the right of this slide, which include the instruction and the taxonomy by Barrett, the definition of the 4 levels that you can see in the screen. The prompt is presented in this slide in English, but the experiment was made in Spanish because the textbook and the activities we use were in Spanish. As part of the results, at the right of the screen, you can see a table with the classification made by the evaluators and ChatGPT, where I highlight that activities 1 and 4 exhibited the highest levels of agreement with rates of 77 and 67%. And also activities 2 and 3 show the lower level of agreement between ChatGPT and the experts, around 50% each. ChatGPT performed best on tasks with lower cognitive demands, such as literal comprehension and inferential comprehension, but its accuracy decreases for tasks requiring higher cognitive skills, such as reorganization of information and critical reading. So in conclusion, our results indicate that ChatGPT performs well when classifying tasks at lower cognitive levels, often aligning with human evaluators. But however, its accuracy decreases as the cognitive demand level increases, particularly in tasks that require abstract reasoning or do not rely on explicit information. An interesting finding is that in some cases, the low agreement between ChatGPT and the expert may not be due to the ChatGPT limitations, but rather to a lack of consensus among the experts themselves. This highlights the inherent subjectivity involved in task classifications, which is pointed by experts anyway. For future research, a potential direction could be to analyze ChatGPT performance at each specific complexity level within a given taxonomy that may be not the same that we use in this study, providing a more detailed assessment of its strengths and limitations in educational settings. And with that, I conclude our presentation. So thank you very much.
Thank you so much for your presentation. Ma'am and sir, do you have any questions?
Anshika ma'am, am I audible?
Yeah, you are audible, ma'am.
Oh, thank God.
You-
Okay. Okay, the Connie question for you.
Okay.
You have mentioned the 3 steps methodology for your automating the classification of educational activities, right?
Yes. Correct.
So what are the potential challenges in implementing this methodology for the large scale? And what are the resources or the infrastructures would be required to support such an implementation?
Yeah, as I mentioned, ChatGPT seems to be well in lower level of cognitive demands, but not so well at higher cognitive demands. So I think that we should carry on that and see if this tendency keeps repeating as we do different experiments. I think that should be carried out in the future, and we're intended to do so in different subjects, not only in Spanish language, for example, also to be in math or history or science.
Okay. Why you select this Barrett taxonomy for your specific aspects of application?
Reading comprehension seems to be really important in the educational field, so this could be really helpful for teachers or schools that design questions, activities, or tests, which is one of the most important subjects in education with maths and science, I guess. So we tried with this taxonomy specifically for language, Spanish in this case. But we also in the past we made already this study with a taxonomy in math. So that's why we decided to try to see if in the Spanish language we could get the same results.
Okay, nice.
Thank you so much.
Sir, over to you if you
Yes.
want that to ask.
Okay.
Sir, do you have any questions? I guess no questions then. So we'll be moving on to the next presentation now.
Yes.
Okay, thank you.
Next up, we have Larissa to present the paper titled Comparison of Machine Learning Algorithms in Water Quality Index Prediction, a case study in Juiz de Fora, Brazil. Are you there? Larissa, are you there? Yeah, we cannot hear you. I can see your video on, but we cannot hear you. Yeah. Sure, no problem.
Hi, can you hear me?
Yeah, we can hear you. You may please begin with your presentation now.
Okay, 1 minute, I can. My screen.
Yeah, you can share your screen.
Okay.
Yeah, your screen is visible. You may start.
Okay. Good afternoon, everyone. My name is Larissa de Lima Silva, and today I will talk about my research on comparing artificial intelligence algorithms for prediction water quality in the Paraibuna River in Juiz de Fora, Brazil. These studies looked at different machine learning models to provide a faster and a cheaper way to check water quality. Let's begin. Checking water quality is an important but difficult task. Traditional, 1 minute. Okay, sorry. Let's go. Traditional methods need lab tests, which are expensive and take a longer time. Machine learning can help in making predictions faster and more accurate. In this study, we compare different regression models to estimate water quality based on different environmental factors. We used data from 16 points along the Paraibuna River in Juiz de Fora, Brazil. The dataset has 727 samples collected from September 2011 to March 2023 and include 48 water parameters such as air and water temperature, pH, turbidity, dissolved oxygen, nutrients like nitrate and phosphate, heavy metals, and other substances. These factors are important for checking water quality. Before using machine learning models, we prepare the data. First, you normalize some, use the min-max method to scale values between 0 and 1. And if feeling missing data, we use two methods. You use a key square, which fill missing values basically how often they appear. And you use copulas, which creates a new data similar to the original. These steps make sure the data is consistent and helps models give better results. Okay, the techniques. To improve model performance, we select the most important parameters. Use three techniques. Technique 1, use dissolved oxygen, pH, total coliforms, biochemical oxygen demand, nitrite, total phosphorus, turbidity, and total solids. And technique 2, you use alkalinity, nitrate, hexavalent chromium, mercury, dissolved copper, total iron, and soluble iron. And technique 3 use the find the most important variables for the algorithm gradient boosting. You use total coliforms, turbidity, E. coli, suspended solids, dissolved aluminum, alkalinity, and pH. We test several machine learning models to predict water quality. First, we look at the sample models. You test the linear regression and where R squared of 0.4224 for X model and 0.4231 for X model 2. 2 shows a low accuracy. And you tested the excision tree, you performed better, but which are square values of 0.5843 and 0.5860. And support vector machine gave it a R square as 0.6760 and 0.664, showing a good performance, and handle force improve even more, reaching 0.7808 and 0.7909. Now let's look at example models which usually perform better. We also test like a precision, use a precision recall, F1 score, and AUC. Ensembles methods, you use a light GBM, extreme gradient boosting, cat boosting, extra tree, and handle forest. These models outperform traditional algorithms and they show a high accuracy. Let's show all the results to predict water quality. We use R square values to measure accuracy. Let's result. Linear regression is 0.3093, show a low accuracy. Key nearest neighbors is 0.5 show a moderate result. Support vector regression showing a good performance, so 0.6702. Decision tree R square is 0.7889, is meaning better accuracy. Handle forest is a 0.8813, meaning very strong. Extra tree is 0.8955, a bit better than handle forest. A cat bush is a 0.8994, is meaning very good result. Gradient boosting is excellent for 0.9033. Extra gradient burst is 0.9274, is one of the best, the models. And finally, light GBM is 0.9276, is being the best model overall. In conclusion, machine learning scheme predict water quality with high accuracy. The best model were light GBM and extreme gradient boost, around R square 0.9276. And for the next steps, I want create a real-time monitoring system for the water prediction, and we use more advanced AI techniques to make a model even better. Thank you very much. I will now happy to answer any questions.
Thank you so much for your presentation. Ma'am and sir, over to you if you have any questions.
Larissa, am I audible?
Hi.
Yes.
Yes.
Have you tried all these algorithms by your own on one same system?
Sorry, I don't understand. Can you repeat?
You have tried, I think, 9 to 10 algorithms, linear regressions and all these algorithms. So you have tried on your systems all these algorithms?
The other systems.
Algorithms. Okay. See, next question for you is.
Okay. Let's go.
You have automating the WQI calculation process, right?
Okay.
You have automated, right? So what is the data inputs are required for it and what exactly the output of that system? Got it? Got my question?
That's a interesting point. I will need to check the data to give a precision answer. Well, it depends.
I can't hear you.
Hi?
Yeah.
Can you hear?
Yeah, we can hear you. Can you please repeat?
Can I repeat the question or Larissa is going to tell the answer again? What?
Larissa,
Okay.
can you please tell your answer again?
Can you repeat the question, please?
What kind of the data inputs are required for your automating the WQI calculation process?
Okay,
And
okay.
what is the output of that process?
Yes, yes. Uh, we need the imputation because the missing values is the necessary for the machine learnings, and we try for the better performance for the the algorithms as machine learning.
I think you don't understand my question. What is the input is required for checking that WQI calculation process? So to check this water quality index, we require some input, right?
Yes, right.
So what is that input I'm asking you? What parameters or what features we are considering to calculate this WQI value?
Okay, okay. The the to calculate the water quality is traditional is a parameter. For example, dissolve oxygen and pH and is the public. So the machine learns the the uh, show the importance for imputation in the algorithms. We test very imputations at different parameters. So the better for the show for your for the better result. We try a very parameters.
Okay, okay, good.
Thank
We'll start with the next presentation.
Thank you. Thank you.
Thank you. So I guess we'll be moving on to the next presentation now. Next, we have Adnan to present the paper titled Extending X Reason Formal Explanation for Adversarial Detection. Are you there?
Yes, I'm here.
Yeah, you may please start with the presentation.
Mm-hmm.
I'll just allow you to share your screen. Yeah, you can.
Okay. Can you see my screen?
Yeah, we can see your screen. You may start with the presentation.
Okay. Thank you very much. Good afternoon, everyone. So I'm Adnan Rashid, and I'm a postdoc fellow at Concordia University, Montreal, Canada. Today, I'm going to present our paper, which is Extending X-Reason Formal Explanations for Adversarial Detections. So my co-authors are Amira Jema and Sufyan Tahar. I'll start my presentation with an introduction and motivation to the topic. This will be followed by the framework that we proposed in this paper. Then I'll show you how we generated and detected the adversarial examples. This will be followed by a network security application where we applied our proposed framework. And then I'll conclude my presentation. Now, moving towards the trend of AI that we have nowadays, it is a kind of thing that is somehow used in every application and most particularly in many safety critical applications. And one of them is medicine, I mean, where you can use in different perspectives. So for example, you have some morphine pump, which is generally used for, drug delivery. And if you use AI in future in this kind of device, it may fail to save a patient because of its, opaque algorithm. Maybe it could give some kind of, fatal dose. And if it may somehow come up with the death of the patient as well. Now, where is the problem, Lok? How could you trust these systems which you do not understand? I mean, you do not know what's going inside of them. So how could you trust them? Now, if you look, from the inside, so the algorithm you followed, it is based on some learned logic. But where comes the problem then? The problem is that that logic is not accessible and explainable. You do not know what's going inside of it. So it could really run into kind of critical vulnerabilities when you talk about these medical systems. So one of them is lack of explainability, which means that that fatal dose problem or excessive dose problem happened due to the unavailability of comprehensible reasoning. How could you overcome this kind of problem? You can use explainable AI, right? I'll describe what it is exactly. The other vulnerability could be potential malicious manipulation. So what threat it could put actually on your system is that malicious actors can manipulate the dosage logic. Again, it could really manipulate logic, and then you end up with high dose maybe. Now, to categorize that problem, you can use adversarial examples. Now, moving towards XAI or explainable AI, this helps us understand how AI makes decisions. If you talk about the traditional AI that we use nowadays, you give some kind of input to that model, any model, and you get some kind of output, but you never know what's going inside. It's a kind of black box for you. You never know how you're making decisions, what kind of biasness, what kind of patterns are used within that decision making. So to get out of this kind of problem, you go for explainable AI, so which makes invisible visible and understandable. Now, if you talk about the traditional XAI tools, there are some tools that you use, which of them are SHAP and Lime. So they are somehow good tools to provide you some kind of explanations for the AI models, but they suffer from some of their inherent limitations. And one of them is explanations are sometimes only locally valid. So they are not valid generally to any kind of generalization. So for example, if we take a data set from breast cancer problem, this is one sample. You can see we have different kinds of features over here. So you see, these are the two most important features that produce kind of target, which is 1 in this case. Now, you can see the same values of those two parameters. You can get another different prediction, which is 0 now in this case. So it means that this kind of prediction only holds locally. You can't generalize this. You can't say, you add a few other parameters or a few other, and then you can get the same kind of prediction at the end of the day. So it means that in these cases, those explanations, they hold locally only. And the second problem is that explanations can be inconsistent. For example, if you take the same sample from the data set, you see these are the two most important features that contributed for the prediction, which is again 1. But another set of important features, another combination of important feature that again results into kind of same prediction, which is 1. So this means that you cannot say by looking at a predicted target, which is 1 in this case, that which features are important, which features are contributing to the prediction, which is 1. Sometimes it could be XY feature, sometimes it could be XZ feature as well. So this means that if you use your tool multiple times, you may not end up with the same kind of explanation. So this means that there is a kind of, it's a kind of very critical factor. You have to take care of this fact when you use that in medical systems. The third one is that explanations can be overly detailed. We know, a few parameters are very important, or features are very important for some prediction, but you may have more than a few parameters. So which means that you are giving a kind of explanation which contains more details, rather you only need a kind of, minimal explanation that could give you a kind of predicted target in that case. So these are some kind of problems with the traditional XAI approaches. To get rid of these problems, you go for formal XAI. So formal XAI means that in this case, you actually combine formal methods with XAI. So if you talk about formal methods, so these are the mathematically rigorous techniques that you use for modeling and verification of the systems. So they are somehow well suited for the safety critical system and medical system or medicine area is one of the critical systems that we have. Now, there are different types of formal methods. One is model checking, theorem proving. I would not go into details of them because I have to focus on the other things that we incorporated in this paper. The third one is SAT or SMT solver. So this is something that we are using in this paper. So it is based on modeling your system using Boolean expressions. And then you check the validity of those expressions to see if your model is doing good or not. So this is how you use SAT solver. Now, what we get at the end of using formal XAI, so you get mathematical rigor, which is very important because you use logic and deductive reasoning. So you can ensure that whatever explanation you are getting, it's somehow accurate explanation. Then you have logical consistency, which means if you use that model multiple times on the same instance, you get the same results. I mean, there would not be any kind of variations. And the third one is minimal explanation. So you get the set of least important features or the minimum number of important features, and that produce some kind of prediction for you. So this means that the explanation would be minimal, and then it would be simple as well. Now, talking about the adversarial example, they are the input crafted to mislead AI models. So for example, you have Panda, and then you add a kind of perturbation into that. It gives you Gibbon. Now, you did a kind of small perturbation, but you see it has totally changed your input. It has misled your model at the end of the day. How it looks like if you talk in the perspective of AI model and the corresponding data. So I took the same sample from the best cancel example. We have two most important features over here, highlighted with the red, and it gives you a kind of prediction as one. And you see, I just changed those two values, a little bit, maybe, and I ended up with a different prediction, which is 0 now this time. So it means that if you add a little perturbation into your input, it could really mislead the model, and then you end up with some different prediction. And I think, again, it is very important as far as the critical nature of the system is concerned. Now we know that the problem is that you can't use traditional AI because it could really would not give you any kind of information or explanation of the system. You use formal XAI for that. And then we focused on a tool which is known as XReason, and there are certain reasons for that. One of them is it was open source. It uses MaxSet solver, and it could give you a kind of explanation that correspond to the model formally. And then there was some issues with that with that tool, by the way. It lacks scalability. It only support one model, so we try to somehow enhance those models. And then it has a limited explanation scope as well that I will discuss later on. We proposed a tool enhancement in the tool XReason by saying XReason Plus. So one of the aspect was we added another model, which is LGBM. We provided class-wise explanation. So I told you, like earlier, it was giving you local explanation. So class-wise means that you have a kind of intervals for the feature selection, for the most important feature selection that could contribute. Yes,
Sorry to
please.
interrupt you, but you have 2 minutes to conclude your presentation.
Sure. I'll try to get back to the results. Now, and then the third one was generate and detect adversarial examples. So I'll only focus on generation and detection of adversarial examples due to shortage of time. So I'll skip the methodology, by the way, or maybe I can show the methodology and then I can show one or two slides for the result. So what happens over here is that we have the traditional machine learning models, which is XGBoost, that was already present in XReason. We added LGBM, we give training data to that. The model is trained. Then it goes to the MaxSet solver, which is a formal framework for us. Earlier, it was only providing local explanation. Now we came up with a kind of class-based explanation. And then we somehow developed adversarial attack unit that somehow generates those samples as well as detect them as well. Now I'll skip this one. So at the end of the day, we applied our framework on network security case study. So we took a data, which is a very useful data set. So it is Canadian Institute for Cybersecurity Intrusion Detection System. So these were the details about that. And this was somehow modified by some other authors where we have total records of that much, 19 features, and then we have only 2 a kind of types, which is attack or normal. So our data is attacked or it is normal. We generated the adversarial examples, right, using XReason Plus, using two other models that are available in literature, and we ended up with the adversarial data. And if we look at the comparison of those results, so XReason Plus generated data with 31% of the data set that was tested for the model that fooled the model. It means that this was the adversarial data, by the way. Whereas the average distance was 1.67. Average means that the original data and then its corresponding malicious data. So you just take the difference of those two data. Whereas for the other two methods, we got less number of less percentage of full samples, whereas the average distance was 0.11 for the case of CW, and the average distance means that you are only doing a little manipulation in your input. So that's why we can see we ended up with generation of more full sample. And if we talk about the detection of the data, so it means that we ended up with 61% of the adversarial samples that were detected correctly by our models. If you have like 2A21 samples given as a test data to your model, our model was able to identify 61% samples as adversarial, whereas the rest were considered as the normal samples, which again was not accurately detected. Then I'll conclude my presentation. So we somehow added a few contributions to the XReason tool to come up with XReason Plus, and then these are the some of the future directions that we want to incorporate. So we want to incorporate more machine learning and deep learning model to get a kind of broader applicability of the tool that we have, and then we want to enhance the adversarial detection as well, so that we can improve the accuracy of our detection, as well as we can use it in different kinds of critical applications as well. Thank you very much for listening to the presentation, and now any questions you can ask, please.
Thank you so much for your presentation. Ma'am and sir, do you have any questions?
Yes, Adnan.
Yes,
The question for you is, you evaluated evaluation is your evaluation is done for this CCIDS 2017 data set, right?
yes, a modified version of that data.
Okay. So, but what are the key characteristics of that data set that makes it suitable for evaluating your adversarial detection methods?
Actually, this data set was somehow the number data. I mean, it was not having any kind of images, right? And it was having different features. As I told you, like there were 80 different features.
So what are those features?
Yes, right now I don't have those in my slides. Maybe you can find more details in the paper. So we somehow skimmed that data, because if you go with 80 features, so it end up with some kind of computational power limitations. You are not able to somehow train your model. So we reduced that into 19 features. And then somehow the 14 attack types, they were reduced to only 2 attack types, where you declare that as normal and attack one. Right now, I may not be able to give you exactly the names of those features that were present in those 19 features, but definitely they can be found in the paper that we have.
Okay, no problem. At your slide number 21, there is architecture. So what
Yes.
is actually exactly difference between this XGBoost and light GBM?
Actually, both models are tree-based model, right? But LGBM is somehow giving you a kind of scenario where you can handle more complex systems or more complex data sets. I mean, if you have kind of problem where you have a larger data set, you can easily handle, or you can get better results for LGBM in correspondence to XGBoost. But if you talk about the general categorization of these two models, I really feel they both belongs to the same family, and they both are tree-based models. But one has capability of handling more complex, more larger problems with respect to the other one. But adding on top of it, like one of our future directions is that we add some more machine learning models that do not only belong to this family of XGBoost and LGBM. It should be some rather complex model that could incorporate more problems as well, other than these simple problems.
Okay, got it, Rajni. Now we will go for the next presentation. Thank you.
Thank you so much, ma'am. So do we have
Thank
any
you very much.
questions?
Yes, please. Yes, you speak, please.
Yeah, I guess no questions then. So we'll be moving on to the next presentation now.
Thank you
Next,
very
we
much.
have Ayush Verma to present the paper titled Insurance Fraud Detection Using Machine Learning. Are you there? Ayush, are you there?
Hello, can you hear me?
Yeah, we can hear you. You may please begin with your presentation.
So I would like to present my screen.
Yeah, you can present your screen.
So my research is on insurance fraud detection using machine learning with my co-authors Krisha Patel and Mr. Hardik Jeshwal. So first of all, I would like to introduce myself. I'm Mr. Ayush Verma, pursuing from Charusat University, and I'm BTech IT student. So purpose of this research is this research was conducted to develop an efficient and accurate fraud detection system. So nowadays there are many fraud detection systems have been created, but not such algorithms are used in machine learning. And fraud detection is very important nowadays in terms of insurance fraud detection here. So improve fraud detection accuracies while reducing false positive rate, handle large and complex dataset efficiency, enhance decision making for insurers through data driven insights. Okay, so I would like to introduce that what is the research. Insurance frauds leads to billions of loss annually, and for gaining their losses or for telling them that you have been fraud, I have used some models like XGBoost, Random Forest, and KNN. You they will say that the they will show you the patterns that the fraud has been detected in such ways. So previously there were algorithms researched, but the gap were generalized across insurance sectors. Like they have given the uh, algorithms on like insurance on car, insurance on money, or insurance on home, but not generalized, not in generalized categorical way. The KNN we are using, it will generalize the category and will show you the appropriate fraud happen in the sector. Imbalanced data handling has been shown in my algorithm, real-time fraud detection. So previously, there were no any research on real-time fraud detection, which I have been providing on this paper. Data collection. So I had collected the data such as employer data, vendor data, claims data, and this will basically help me in training the model and performing the best in train test split. Okay. Purpose methodology. KNN, that is known as K nearest neighbor, and XGBoost. I have been using this methodology. And KNN used for fraud detection by classifying claim based on similarity to past cases. And XGBoost is ensure high accuracy and fast processing, identify fraud detection efficiencies. uh, Data collection processes. So this is the basic process I have been using: data collection, then data pre-processing, feature selection, ROC curve analysis I have been providing, and between that training testing model split is been there. Okay. So for dataset 1 results, I have been getting XGBoost performance best with low MSC, RMSC, and MAE. My KNN and render boost has slightly higher MSC and RMSC, as we can see in my ROC curve analysis. So dataset 1 has been good, performing well. Whereas in dataset 2, random forest performs best with the MSC and RMSC scores. KNN had the lowest MAE, where R2 including poor fits, as you can see in ROC curve analysis. And result with the score, I have the falsely positive rate, false positive MSC, RMSC, ME, and R2 scores, right? KNN have the best in all of the three particular scores, And also I have been providing the graphs that shows MSc, RMSc, MAE, and R2 scores. So in the conclusion, I would say that the fight against the insurance fraud demands innovative solutions driven by modern technology using that AI and ML. So ML models will be trained according to the data sets, and they will be provided the particular results to the user. Also, in futures, we can add like an app. We can give an app to the user for the particular enhancement of the machine learning model, as he or she can be effectively shown there where the insurance fraud has been caused. So this was my presentation, short and simple. So I would like to ask that any questions further, please.
Yes, your presentation is short and simple.
Yeah.
Now, question for you is,
Yes.
see, we know whatever the fraud we have, that frauds are dynamic in nature, right?
Yes.
And it evolving tactics of fraudsters. So,
Mm.
how adaptable and scalable is the proposed methodology to the new types of the frauds or the changes in data patterns? Means what mechanisms are placed to ensure your continuous learning and improvement of the model? Got my
So,
question?
yes, yes, perfectly. So like the purpose methodology will have that uh, continuous data, as you said, that in continuous data set or in dynamic proposed, the model will be trained atomically. And also in future we will be making we will be including some CNN models, as they will be more efficient in nature, to like they will be more effective less they will be more effective.
Okay, so now you have not used any models which are continuously learning and improving your models, right?
No, they will be used in CNN. I will be used in future perspective.
Okay, so you have used the metrics like MAE and R square.
RMS, yes, yes.
So can you tell me what is the meaning of R square? What exactly that
R,
metrics evaluate? Huh?
so R2 score represent the error of the particular given data set.
Error of what?
Error of particular given the value I had particular given to the score.
And MAE?
ME is the like RMSC rate like how I can explain.
RMS is different and MAE is different, right?
Yes, yes, yes. I know. R2 score represent the like yeah. How can I say? Like so like particularly MA is a mean absolute error. It will show the
Hmm.
absolute error, right? And R2 score is the rate error score that will be shown to you.
Okay. Okay. Okay, Ayush. Good. Now, Anshika ma'am, we will continue with the next presentation.
Thank you so much, ma'am. Thank you so much for your presentation. Um, so I guess no questions. So we'll be moving on to the next presentation now. So next we have Honorato to present the paper titled Modeling and Simulation of Mushroom Cultivation in a Protected Environment Using Fuzzy Logic. Are you there, sir?
Okay, thank you.
Yeah. Your screen, sir. You may begin.
Good afternoon, everybody. My name is Honorato. My presentation, modeling and simulation of mushroom cultivation and protect innovation using fuzzy logic. The authors by evaluation the analytic activity and spends strategy way for fungi and incubate at temperature of 25 degrees. They managed to completely colonize the substrate used in unexpected and real time. Once the incubation place was finished, they were transferred to fruiting room at 20 degrees to induce the production of basil mats with 18% environment humidity. This methodology might be possible to achieve good results in mushroom cultivation. According to a research carried out by authors in their publication of nutritional advantages for edible mushroom, they report the high protein content compared to meat products, and that this mushroom can be grow in small environments where temperatures and relative humidity can be controlled with easy handling of the substrates used. La Biblio en block coding work research uses a set of experimental prepared with National Instrument Graphical Programming Language LabVIEW. Real-time experiments we prepared according to theoretical structure, and the results were expected. Because of this easy of programming graphically and without the participation of programming experts, the authors of this work applied the LabVIEW software to improve the learning of college students by creating virtual instruments and sophisticated programs using much less time in relation to other types of programming, such as line programming. Objectives: modeling and simulation of mushroom cultivation in a project environment using fuzzy logic, formulation of irrigation time roles within the system and every environment condition, simulation with different variables of mushroom grow and protect environments, short, medium, and high irrigation time. And mushroom cultivation temperature 12 to 25 degrees and humidity 13.5 to 16.5% are chosen as input variables in a protect environment with toothless sangles are recommended by various authors. By controlling the temperature and humidity, we can program the chores or line irrigation time, as these are parameters in which the mushroom develop best according to research. Occasionally, the crop needs to receive sunlight for a short time. These parameters can be programmed according to the element of the product. In fuzzy logic, degrees of food are used as a mathematical model of the phenomena of pageants, miscellaneous statements are classified as intermediate levels of truth within the absolute truth of complete false. Next, the while loops is a method in which the process programming will be carried off, then the program for the curve to the fuzzy logic is added inside the while loop. The fuzzy logic controller is inserted in which the input variables and then the output variables for the production system must go. With this, the process is controlled in the mushroom cultivation environment using the input and output parameters with the support of the fuzzy logic of the LabVIEW software. Structured by loops, system monitoring, low at fuzzy system, fuzzy controller. Variables to Control the mushroom production environment. The input variables were temperatures 0 to 12 degrees. Has the low temperature not recommended for production, average temperature 12 to 25 degrees, which were the temperatures which the set point for the best production was the local and high temperatures 25 to 14 degrees greater than or equal to 25 degrees are considered harmful temperatures in productions. Regarding humidity and collector environment of humidity, 13 to 17% is unfavorable for production. Medium is where the humidity set points bowl, the local and high humidity. Is humidity harmful to crop and could cause rotting in the environment. Regarding in irrigation time is crop it is a short time when you have 0 to 14 seconds. Medium time in which the set points will be located, and high time will be and long irrigation time too much water for the crop. Input variables, temperature, humidity, and temperature cold, temperature medium, temperature hot, and output water time, low time, medium time, high time. The rule is rules. If temperature is cold and humidity is medium, then watering time is low. If temperature is medium and humidity is medium, then watering time is medium. If temperature is hot and humidity is low, and then water is high. Test system, test system when input variable temperature at 20 degrees and humidity 18%, and output variable 515, no, 515, no. And table 2, input variable temperature and output variable water time, temperature cool, more medium, hot, water time, medium, low time, high time. And input variable humidity and output variable water time, and humidity low, medium, high, water time, high, water time, medium, high humidity, low time water. Block diagram with the modeling and simulation program for the control of temperature, humidity, and irrigation time and mushroom cultivation in a protected environment. Visual instrument for modeling, simulation, and controlling the control environment for mushroom cultivation, and sensor temperature, sensor humidity, and water time. Simulation, result of modeling and simulation test for mushroom cultivation in a protected environment. Test one, temperature 15, 18, humidity 35%, water time 14 fourths time. Test 3, temperature at 13.5 and humidity 19.5, water time 22. Test 6, temperature 13.2, humidity
Sorry to
92.
interrupt you, sir, but you have 2 minutes to conclude your presentation.
Thank you. Conclusion, the cultivation of quality mushroom increase and protects environment, and therefore it requires a special of temperatures, humidity, and irrigation time to achieve good productivity. When physiological control is used, the irrigation time is set based of the pre-established values of humidity and temperatures and mushroom cultivation in a protected environment. In a controlled environment for mushroom cultivation, it was possible to model, simulate, and control safe environment for cultivation when the parameters on input variables such as temperature and humidity when the environment and with the irrigation time response to keep the cultivation system stable. Mushroom cultivation in a protected environment with temperature, humidity, and irrigation time control is important since mushrooms have important properties for human nutrition due to protein, vitamin, and mineral content as described by different authors mentioned in this article and research. And gentlemen, thank you very much.
Thank you so much for your presentation. Ma'am and sir, do you have any questions?
Hello, sir. Am I audible?
Hello.
Hi, am I audible?
Okay.
Anshika ma'am, am I audible?
Yes, ma'am, you're audible.
Okay.
Yes.
So, sir, the question for you is, how many rules you have written, fuzzy rules you have written for your system?
Please repeat.
Whatever the rules you have written, you have a rules in your fuzzy system, right? So that rules decided by you, or you have taken any standard rules for your system?
It is using an industrial food processing and other processing.
See which member function you have used. Member function, which member function you have used?
It is very functional to simulation and control.
So there are multiple member functions like triangular member function, trapezoid member function, Gaussian is there. So which you have used? Okay, fine.
I guess there's some connection error from his side.
Okay, no problem.
We can move to next, right?
Yes, we'll continue with the next.
So we have come to the end of the session. I
Oh,
sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. And all the papers have already been forwarded to Sprinter. The publication will be live within 6 months, so kindly cooperate with the team of ICICT 2025. Before ending this session, I would like to take a moment to thank our chair for the session, Professor Eduardo, for chairing this session. Thank you so much, sir. Would you like to share a quick closing remark with us?
Thank you so much.
Okay, thank you, sir.
It's okay.
Yeah,
Thank
I
you.
would also like to thank Professor Poonam for chairing this session. Ma'am, this is a token of appreciation to the chair. On the behalf of whole team of ICICT 2025 and Global Knowledge Foundation and partners, thank you for chairing this session. Would you like to share a quick closing remark with us?
Yes, thank you, Anshika ma'am. I would like to thank the ICT 2025 organizing committee for the opportunity to serve as a session chair for this session. Then again, the session have the exciting applications of advanced technology across the diverse fields. So we saw innovative uses of machine learning for critical tasks like water quality prediction, then insurance fraud detection, and highlighting the potential of AI to address the real world challenges. Then the research on blockchain based investment platforms, which demonstrate the potential for increased security and efficiency in financial system. Again, we have seen this exploration of explainable AI for adversarial detection in cybersecurity, which is also crucial for building the trust in AI system. Finally, we have seen this fuzzy logic-based approach, which is used for optimizing this mushroom cultivation, which illustrates how intelligent systems can improve agricultural practices. So all these presentations are, we can say that it is collectively demonstrate the power of interdisciplinary research to drive the innovations and create the impactful solutions. So thank you all the presenters for their valuable contributions, and also thank again to ICT 2025 organizing team. Thank you.
Thank you so much, ma'am, for sharing this session. Before ending this session, I would request everyone to kindly turn on their cameras for a quick snapshot. Thank you so much, everyone, for your presence. Take care, stay safe. Bye bye. Thank you, everyone.